The universe is expanding, but not just expanding, it's doing so faster than scientists ever predicted. This puzzling phenomenon, known as the Hubble Tension, has left cosmologists scratching their heads. According to our current understanding of physics, the expansion rate of the universe, described by the Hubble Constant, should align with predictions based on observations of the cosmic microwave background, CMB, the afterglow of the Big Bang. However, more recent measurements of distant galaxies and supernovae indicate that the universe is expanding significantly faster than these models suggest. So, why is this happening? Several hypotheses have been proposed to explain this discrepancy. One possibility is dark energy, a mysterious force that makes up about 70% of the universe's energy content and is believed to be driving this accelerated expansion. Some scientists think dark energy might not be constant, but rather evolving over time, exerting a stronger influence than initially thought. Another possibility is that our understanding of gravity and fundamental physics might be incomplete. Perhaps Einstein's general relativity requires modification at cosmic scales. There's also speculation about new, undiscovered particles or forces that could be influencing the cosmos in ways we have yet to detect. But what does this accelerated expansion mean for the fate of our universe and our existence? Scientists have proposed several potential end scenarios based on current observations. The Big Freeze. If dark energy continues accelerating the expansion indefinitely, galaxies will drift further apart, stars will burn out, and the universe will grow cold, dark, and lifeless. Matter will be so dispersed that no new stars or structures can form, leading to a slow heat death, where entropy reigns supreme. The Big Rip. In this more dramatic scenario, the expansion rate accelerates to the point where even atoms are torn apart. Galaxies, stars, planets, and eventually atomic particles themselves would be shredded as the fabric of space-time stretches to infinity. This would spell an abrupt and violent end to everything. The Big Crunch, or bounce. Some theories suggest that the expansion could eventually slow down, reverse, and collapse the universe back into a dense, hot state, possibly leading to another Big Bang and the birth of a new universe. However, current data favors continued expansion rather than contraction. The multiverse hypothesis. Some physicists speculate that our universe is part of a much larger multiverse, where different regions expand at different rates. If this is the case, the accelerating expansion could be a sign that our universe is just a bubble within a vast cosmic landscape, with other universes experiencing different fates. With other universes experiencing different fates. What does all of this mean for humanity? In practical terms, the accelerated expansion doesn't pose an immediate threat to our daily lives. However, it does challenge our understanding of the fundamental laws of physics and our place in the cosmos. As the universe expands, distant galaxies will eventually move beyond our observational reach, limiting our ability to study them and uncover the deeper mysteries of existence. Ultimately, the question remains, is the accelerated expansion an inevitable path to cosmic isolation and decay, or is there something we have yet to discover that could change our fate? The answers lie in future observations, deeper understanding of dark energy, and perhaps entirely new physics yet to be uncovered. The universe's expansion has been a subject of fascination since Edwin Hubble first discovered it in the 1920s. Scientists initially believed that gravity would slow down the expansion over time, but observations from the Hubble Space Telescope and other missions have revealed that the expansion is actually accelerating. This unexpected acceleration is attributed to a mysterious force known as dark energy, which makes up about 70% of the universe's total energy content. Dark energy acts as a repulsive force, counteracting gravity and driving galaxies apart at an increasing rate. However, its nature remains one of the greatest mysteries in cosmology. The supernova surveys, such as those from the Sloan Digital Sky Survey, SDSS, show that distant galaxies are moving away faster than expected, confirming that expansion is accelerating. Imagine inflating a balloon with air. Initially, it expands at a steady rate, but if you suddenly introduce a mysterious gas that pushes outward more forcefully, the balloon's expansion accelerates beyond your expectations. Scientists use the Hubble Constant, H0, to measure the rate of expansion, but different methods yield conflicting results. Observations of the cosmic microwave background, CMB, the afterglow of the Big Bang, suggest a lower value, while measurements based on supernovae and local galaxies suggest a higher rate. This discrepancy, known as the Hubble Tension, implies that our understanding of fundamental physics might be incomplete, or that new physics beyond the current standard model of cosmology may be required. Different telescopes, such as the Planck satellite, studying the CMB, and ground-based telescopes, studying nearby galaxies, provide slightly different values for H0, raising debates in the scientific community. It's like using two different clocks to measure the same event. One may be slightly faster than the other, suggesting an underlying calibration issue or missing variable. Dark energy, often described as a property of space itself, seems to be increasing the separation between galaxies. Some theories suggest it is related to the cosmological constant L in Einstein's equations of general relativity, representing a constant energy density in space. Others propose that dark energy could be a dynamic field evolving over time, which could drastically change our predictions for the universe's future. Observations of distant supernovae have shown that the expansion rate was slower in the past but has picked up speed in the last few billion years, indicating the growing influence of dark energy. Think of a race car accelerating gradually but then suddenly getting a boost from an unknown source, making it go faster than expected. Depending on how dark energy behaves in the future, several possible fates of the universe have been proposed. If expansion continues indefinitely, galaxies will drift apart, stars will burn out, and the universe will become a cold, dark, and lifeless place. If dark energy's repulsive force strengthens over time, it could eventually tear apart galaxies, stars, planets, and even atoms, ending existence in a catastrophic event. Alternatively, if dark energy reverses or diminishes, gravitational forces could cause the universe to collapse back in on itself. Simulations by cosmologists predict that in billions of years, galaxies will become isolated due to accelerated expansion, leading to the eventual heat death of the universe. Imagine a rubber band being stretched continuously until it either snaps or returns to its original state. But while the accelerating expansion of the universe happens on cosmic scales and does not directly affect our solar system in the short term, it raises profound philosophical and existential questions. The ultimate fate of the cosmos forces us to consider our place in the grand scheme of existence and how life might adapt or migrate to other parts of the universe in the far future. If the Big Freeze scenario occurs, humanity may need to find ways to sustain itself in an increasingly energy-scarce environment. It's like living in a house where the temperature gradually drops and inhabitants must find new sources of warmth to survive. Some theories suggest that quantum fluctuations in the vacuum of space could be influencing dark energy and the universe's expansion. Concepts like vacuum energy, zero-point energy, and the quantum foam hypothesis propose that space itself is teeming with fluctuating energies that contribute to cosmic acceleration. Experiments at the Large Hadron Collider, LHC, continue to investigate possible quantum effects that might explain dark energy. The universe might behave like a simmering pot of water, where tiny fluctuations can have significant long-term effects. Some scientists speculate that the accelerated expansion of our universe could be linked to the existence of other universes in a multiverse. If our universe is interacting with adjacent universes through unknown forces, it could explain the unexpected expansion rate. The concept of brain cosmology suggests that our universe exists. The inflationary theory of the early universe suggests that space-time may have expanded from a much larger, multi-dimensional structure. Picture soap bubbles floating in water, where unseen currents can make some bubbles expand faster than others. While humans currently have no means of affecting cosmic expansion, understanding it may open possibilities for advanced civilizations to manipulate space-time for interstellar travel. Theoretical concepts such as warp drives, wormholes, and energy manipulation based on dark energy could be harnessed in the distant future. Scientists like Miguel Alcubierre have proposed theoretical models where space-time could be contracted and expanded to allow faster-than-light travel. Changing cosmic expansion would be like adjusting the speed of a moving escalator to control where and when you arrive at your destination. The accelerating universe challenges our understanding of reality and forces us to rethink concepts of time, space, and existence. It raises questions such as whether the universe has an ultimate purpose, whether it will end, or if new forms of life and intelligence can emerge in an evolving cosmos. Many philosophical perspectives, from existentialism to cosmotheology, have pondered humanity's place in an ever-expanding universe. It's absurd. Why would anything have purpose? It's so easy to become disconnected from the universe. It can't be real. Our existence in the expanding universe is like a traveler on an endless road. While the journey continues indefinitely, the meaning of the destination remains unknown. The rapid expansion of the universe remains one of the greatest unsolved mysteries in modern science. Whether driven by dark energy, quantum effects, or interactions with other universes, understanding this phenomenon is crucial for predicting the ultimate fate of our cosmos. While humanity's short-term existence may not be threatened, contemplating these vast cosmic changes helps us appreciate our place in the grand tapestry of existence. And